Okay, so another example of where oxidations have been used in uh, real life, I guess this is chemistry life too, is to test for aldehydes and ketones. So back in the day, before there were computers and instruments that we could use to kind of like take pictures of molecules, we don't necessarily take pictures of them, but we get data that we can correlate and figure out what the molecule is. Well, organic chemists didn't have that. They didn't have computers back in the 1901, let's say. They didn't have computers. And so they had to devise tests to figure out what they had in their solution or what molecule they had. So they would take small itty bitty portions of the molecule they made and try all these different tests. And if it was positive or negative, they could then get hints as to what the molecule was. So tests for aldehydes and ketones were super common. So in the synthesis of some molecules, sometimes you could get things isomerizing or moving around unknowingly. And so you'd want to test if you thought you made an aldehyde, you want to test to make sure you made it. So Tollens is the name of the guy who made the Tollens test. And he made a test that when you add silver ion, so silver plus, with aldehydes, it will oxidize aldehydes and produce a reaction, but not with ketones. So you can, if you're not sure if you have an aldehyde or a ketone in a molecule, you can tell based off of the reaction or the color change. So in this particular reaction, let's do gray and see if it works. If you mix an aldehyde with our silver plus with an oxidant, you end up getting two silver zero atoms plus your carboxylic acid. If you have a ketone here, the ketone doesn't have any CH bonds to oxidize, so you don't have any result with this. And what you look for is this silver zero. So this is just pure metallic silver. And that has that stereotypical shiny metallic look, whereas silver plus doesn't have that metallic look. It's typically like a white powder, honestly. It kind of looks more like salt because you have it mixed with something else. And then when you reduce it, or when you oxidize the aldehyde, you get silver zero, and it's that silver metal, and you can see a metallic sheen in your reaction. So I'm actually going to do this for you guys, and on our next class period, you guys will see this in person or over video, but in person, I will do it. And you can see that whatever material or whatever glassware you're holding this test in will turn into what looks like a mirror. So this is actually the same process that they use nowadays to make mirrors as well, to do silver plating on mirrors. So if it's like an olden mirror and has actual silver, they take a piece of glass and then put a solution of silver plus and an aldehyde in on top of it, and then let the, after the oxidation goes, they let the silver line and make a super thin layer of silver on that glass, and that's a metallic or a mirror surface. So this is also kind of called like the mirror test, is one thing that they do, they call it too. A different test that we could do is Benedict's test. So Benedict's test is a little bit different because it gives a positive result only if there's an aldehyde with an adjacent hydroxyl group. So here you see how there's an aldehyde, and next to it there's a hydroxyl group, an alcohol. We add copper plus 2 and an oxidant, then we overall get, resulting out of there, Cu2O, copper oxide, plus our oxidized aldehyde. And this is a positive test, would be a brick red solid. So copper oxide is often the color of, like, I mean, bricks. It's what's in bricks. So that gives it that stereotypical coppery red color. So if you have specifically an alpha, or I'm sorry, an adjacent hydroxyl group to an aldehyde, is only when this will work. If you just have an aldehyde, it won't work. So these are some examples of tests that they used to do back in the day to see what they had in solution. And these are both particularly useful for sugars because you can see here we have that, alpha, or I'm sorry, an adjacent hydroxyl group to the aldehyde. So you can see if you have sugar, you can test the amount of sugar in something or see if you have it. So let's do a little bit of practice. What test would give a positive result for the following molecules? This molecule here, this first one, we have a ketone and an alcohol. So we do have the alcohol adjacent to the ketone. However, the ketone cannot be oxidized. It has to be an aldehyde. So no test. Okay, over in this middle molecule, we have an aldehyde, which is good, but then we also have an alcohol. So it could be both of the tests, it could be one of the tests. Which one is it? Well, we definitely know because there's an aldehyde, the Tollens test is going to give a positive result. And then now we need to look and see if the hydroxy group is adjacent to the aldehyde, which it is not because there's a carbon in between. So it's just the Tollens test will give a positive result for this molecule. Okay, and then over here we have an aldehyde and then two alcohols. In this case, because we have an alcohol, we know that the Tollens test will work. And then let's see if our alcohol is adjacent. So it is. So in this case, both tests are going to give a positive result. So both Tollens and Benedict's test would have a result, whereas in the middle molecule, only the Tollens test would have a result. So if you had a molecule that you weren't sure if the hydroxyl group was adjacent or maybe further down on the molecule, this would be something you could do to figure it out, see if it reacts in the Benedict's test. Okay, I think that's all for this video.